Okay, so can we just cancel these out? That's the big question. Can we just cancel out arcsine and so we like just go boom, boom. The answer is just 9 pi over 2. Well, the answer to that is depends. Only when the 9 pi over 2, right there, the argument, the plug-in, is, let's say inside, is inside of the limited domain. Remember, we limited things for the inverse trig functions. So, okay, so what's the limited domain? Well, first off, is this an answer or an angle? This right here has to be an angle. Why is it an angle? Well, because it's inside of a sine, right? It's next to sine. You put angles in sine, cosine, tangent, regular trig function, get out answers. And for an inverse sine, you put in answers, get out angles, right? So this one's got to be an angle because inside of a regular sine function, right next to a regular sine function. So it's an angle. Okay, great. So what? So 9 pi over 2 is an angle. And we want to know, is it within the limited domain? Well, let's go to the limited domain. This is why you want to have this is from the notes. This is the exam 2 notes. You want to have this on your notes when you take exam 2. So we're looking for, what are we looking for? Sine of an angle. So right here, sine of an angle, it's got to be between negative pi over 2 and pi over 2. Quadrants 1 and 4. Yeah, remember, sine inverse is those two quadrants. Negative pi over 2 and pi over 2. Negative pi over 2 down here and pi over 2 up there. Remember that? So that's it. So let's draw that. So we say, okay, so it's got to be between negative pi over 2 and pi over 2. So right here, this is the LD, the limited domain. So where's 9 pi over 2? Is it in there? No way. Huh? No way. 9 pi over 2 is like way over here. Like that. 9 pi over 2 is way over here. Oops, wrong tool there. It's like way over here, right? It's not even, this is only +1 and -1 pi over 2. 9 pi over 2 is way out of there. So no, it's not inside the LD. It's not. So we can't just say cancel, cancel. Answer's 9 pi over 2. Not true. We're not allowed to do that. Well, then what do we do? What do we do? Is it going to be D and E does not exist? No. No, there's going to be an answer. It's just not going to be 9 pi over 2. Well, how do you know it's going to be an answer? Because it's an angle. And even though the angle's not inside, remember with angles, we can always add 2 pi or subtract 2 pi. And it's like a clock going around, 12 hours later, it's going to say the same time. So, right, if we, 2 pi later or 2 pi, add 2 pi, subtract 2 pi, it's going to be the same angle and we can say it differently then. And so eventually we'll get it down where it needs to be and there will be an answer. It's not going to be D and E. The D and E only happens when you plug in something that's an answer that's not inside the limited domain, then boom, that's D and E. But if you have an angle that's not inside the limited domain, you add 2 pi or subtract 2 pi until it'll work. Now, let me be more exactly clear. I updated these notes for you to make them more clear. Here they are we're on step 5. Let me read you the fine print. And I updated this recently to make this more clear. If it is outside of the limited domain and it's an angle, yep, that's us. That's what we're talking about. We have something that's outside, 9 pi over 2 is outside the limited domain and it's an angle. Then we cannot just cancel, as we said, because outside the limited domain, that's the only time you can cancel. But there will still be an answer. It will not be D and E, as I said. It's not D and E because it's an angle, and no matter how big an angle is, we can always add or subtract 2 pi until we find where it is in the unit circle. Okay, so now, here's the new part. This is all new. So what is it? Here's the game plan. Add or subtract 2 pi from the angle until the new angle is one of two things, either on the unit circle or within the limited domain, and there's limited domains again. I don't think I made that very clear before, so now I'm trying to really make that clear. Let me say that again. Are you getting that? What do you do when you have an angle that's not within the limited domain? You add or subtract 2 pi until one of two things happens. Either it's suddenly on the unit circle when it wasn't originally, or it's suddenly back within the limited domain when it wasn't originally. And if it suddenly appears on the unit circle when it wasn't originally, you can work out the problem starting on the inside. That won't happen this time. I'll show you that in another example. If it suddenly gets back into the limited domain, that's super good news, which is what we're going to see on this one. You just cancel it out then. Remember, when it's in the limited domain, it's cancel, cancel, game over. So that's the deal. You add or subtract 2 pi until one of those two things happens, until it's back on the unit circle or back within the limited domain. And either way, you can finish the problem. So that's what we do. I hope this is more clear. Let's do that. So let's take now we're going to do it. We're going to take that 9 pi over 2. We're going to subtract 2 pi because it's too big, right? Over 1. And so you know what I got to do? I got to multiply top and bottom by 2. Get a common denom here. 9 pi over 2 minus, and this will become 4 pi over 2, which will equal 5 pi over 2. 5 pi over 2 is still too big. I mean, it's about right here. It's still outside the limited domain. It's still not on the unit. If you look at the unit circle if you want, 5 pi over 2 is not there. It's too big. That's more than 2 pi. So what do? Do it again. So now take 5 pi minus, and then let's subtract another 2 pi. Put it over 1, top and bottom by 2. And then we get 4 pi over 2, which is 1 pi over 2. Where's that? Right there. Look at that. Boom. We're inside. We're now inside the LD, the limited domain. Boom. We're in there. You see what just happened there? That put us inside the limited domain. What is that? Okay, so what does that do? Well, that means this question, this original question, which was, bring it down from here, which was arc sine of the sine of 9 pi over 2 has broken down to become the arc sine of the sine of what? Pi over 2, or 1 pi over 2, same thing either way. So, right, this 9 pi over 2, which was not in the limited, this was not inside, this was not inside the LD, but this is inside the LD. I don't know if you can read my is there. It is inside the LD. So what do you do when it's inside the LD? What do you do? Remember that's what we answered from the beginning. Can we just cancel them out? Yes, when it's inside the limited domain. So now we're in business. Now we just go boom, boom. Answer pi over 2, or 1 pi over 2, however you want to say it. There it is. So you see the deal. We subtracted 2 pi twice, and 9 pi over 2 became pi over 2 is back on the barely on the edge of the limited domain, but he's in there. So then you can cancel these out, and the answer is just pi over 2. So the answer, we couldn't cancel from the beginning and say it's 9 pi over 2 because that was not inside the limited domain. But when we subtracted 2 pi a couple times, that brought it back to within the limited domain, and then you can just cancel these out, and the answer is pi over 2 because they just cancel out when you've got something inside the limited domain. And 9 pi over 2 is the same as pi over 2 in the limited domain. So they cancel out. Answer's pi over 2. There we go.